In this video, I'll be talking about the idea of equivalent fractions. So let's say we have a pizza and it is divided into two equal halves, and I have decided to eat one half of the pizza. So let's say this half of the pizza has been eaten. So out of total two halves, I have eaten one of them. So in terms of fraction, I have eaten one half of the pizza. Now let's suppose we have another such pizza, and instead of having two pieces, it is divided into four equal pieces. So let me divide it into four equal pieces by having a cut here. Now it is divided into four equal pieces, and I have decided that I will eat two pieces out of total four. So out of total four pieces, I have eaten two of them. Now let's suppose we have a third pizza, and we'll divide it into 8 equal pieces instead of 2 or 4. So I will do my best to divide it equally into 8 pieces. So we'll cut it from here, and then I have another cut here and have another cut here. Of course it's not perfect, but I hope it will give the sense. So now out of these total 8 pieces, let's suppose that 4 of them are eaten. Let's say all of this pizza has been eaten. So out of total 8 pieces, this time 4 pieces have been eaten. Now if you observe closely, you can see that in all three cases, the quantity of the pizza eaten is the same. It means that all these three fractions are equivalent. And also, there is a mathematical pattern followed once we move from one fraction to another. As you can see, the numerator of this fraction is 1 and the denominator is 2. And once the numerator goes from 1 to 2, it has been multiplied by 2. It has been multiplied by 2. Also, the denominator is multiplied by 2 to give us 4. And likewise, in the next case, 2 has been multiplied by 2 to give us 4, and 4 has also been multiplied by 2 to give us 8. So we reach to a result that if the numerator and the denominator of a fraction is multiplied by the same number, the fraction we get in result is an equivalent fraction. Now let's have a look at let's have a look at one more example. Let's say this bar has 4 equal pieces, and 2 of the pieces of those 4 equal pieces are shaded with brown. So out of 4 equal pieces here, 2 are shaded in brown color. Now let's suppose we have another such bar. So I will just copy paste to save time. And in this case, let's say that we split the boxes into further halves. Let's say we split the boxes into further halves. So we'll have like 8 boxes in total. So I will just split the boxes. All the boxes will be splitted into 2. So now I have total 8 boxes. 1, 2, 3, 4, 5, 6, 7 and 8. So out of these 8 boxes, how many are shaded brown? They are 4. I'll do it in the respective color. 4. Now let's have another one, and this time I just want you to think differently. We'll have another approach. For example, we just have 2 equal boxes in this whole bar. We just have 2 boxes, and I will just merge this color this one will be merged. So let's say we have only two boxes. We have only two boxes, and one half of the box is shaded brown, and it means in terms of fraction we can write it as out of two total boxes, one is shaded brown. But as we move from 2 by 4 to 4 by 8, we can clearly see that 2 has been multiplied by 2 and 4 also has been multiplied by 2 to get 4 by 8. This 2 has been multiplied by 2 to give us 4, and this 4 has been multiplied by 2 to give us 8. But in this case 2 has been divided, because 2 has been converted into 1 and 4 has been converted into 2, so it means 4 has been divided by 2 to get 2, and 2 has been divided by 2 to give us 1. But you can also observe that in the figures, in all the three figures, the area of the shaded region is the same. It means these fractions are also equivalent. Now this brings us to the conclusion that whenever one fraction is multiplied by the same number, by fraction I mean to say that its numerator and denominator, both of them are multiplied by the same number, we get an equivalent fraction. And also we get an equivalent fraction once the numerator and denominator is divided by the same number. Let's do a small problem to understand it better. For example, there is a fraction 2 by 3, and we want to get some equivalent fractions out of this through multiplication. So just multiply this, let's say by 2, this also by 2, and it will give us 4 by 6. Let's do multiplication again. To the numerator, let's multiply it by 2 again, and this denominator also by 2, and it will give us 8 by 12. And we can go on, and we can get as many equivalent fractions as we want. But let's consider another fraction. Let's say we have 12 by 36, and now we have to get the equivalent fractions by division. So let's say how many can we get. For example, this numerator and denominator is divided by 2. Since both of them are divisible by 2, so we can straight away divide them by 2, and if we divide both of them by 2, so 12 divided by 2 is 6, and 36 divided by 2 is 18. They again can be divided by 2 or even 3, so let's divide it by 3 this time. So by dividing this fraction up and down by 3, the new fraction we get is 6 divided by 3 is 2, and 18 divided by 3 is 6. This can further be simplified by dividing it by 2 again. So let me do it in another color, new color. So 2 divided by 2 and 6 divided by 2, we get 1 over 3, and we cannot go any further. So here is the limit. So what point I wanted to bring out, that if there is a fraction and we want to get equivalent fractions through multiplication, we can get as many fractions as we want, and this process can go on and on. But through division we will stop somewhere. There will come a stage that we will not be able to go further. For example, from 6 over 18 we got 2 over 6, and then finally we simplified it to 1 over 3. We cannot go any further. I hope this video will give you some idea of equivalent fractions.